Let's try another integration from negative infinity to infinity. Here's a function you've probably never seen before. I kind of just made it up. So 1 over absolute value of x plus 1 times sine of x, but this sine isn't a sine wave, it's SIGN, which is a fairly useful function that gives you a 1 if the x is positive, a negative 1 if x is negative, and a 0 if x is 0. So if it's negative, if x is negative, you're just getting a negative 1, which is like saying, hey, this thing has a negative sign to it. Here's what the sine function looks like. And then if you multiply by 1 over absolute x plus 1, it's basically like 1 over x, so kind of a falling off hyperbola there, but this protects us from a divide by 0. So what do you think the integral from negative infinity to infinity will be here? We've got this positive area, we've got this negative area. What do you think will happen? Well, remember we have to break it into two parts. So we can integrate from negative infinity up to something, and then from that thing up to positive infinity. Let's break it at 0. That seems to be the obvious symmetric place to break it. So let's break the integral from minus infinity to infinity at c equals 0. So let's take a look at the right half of it. So the integral from 0 to infinity, just the right part here, 1 over absolute x plus 1 times sine x dx. So we know here that x is not negative. So if x is not negative, we can drop the absolute value because we know x is not negative. So we can say 0 to infinity, 1 over x plus 1. And then if x is not negative, the sign, SIGN, is 1 plus 1. I'm ignoring the value at 0. If you take later math classes, you'll see that that's okay to ignore. For now, you can just trust me. What is this integral? So let's think about that. You could say, let's do a u substitution. You could say, you remember that the integral of 1 over ax plus b is 1 over a times log ax plus b, like that. So here, b is 1 and a is 0. Sorry, a is 1 and b is 0. A equals 1. Oh, sorry, a equals 1, b equals 1. We're just not writing the coefficient there. So this integral would be the limit, and here I already used b for my upper end. I'll just use like a capital T for the upper end here. The name doesn't really matter. So we can just say log of basically this linear thing from 0 to capital T. And what is that? That would be, let's say the limit as t goes to infinity of log t plus 1 minus log 0 plus 1. What is log 0 plus 1? That's log 1. Log 1 is 0. So we get a 0 there. And what is, if you kind of plug in infinity, you get log infinity plus 1. We'll kind of put quote marks around that because we're not really supposed to write things like that. But what is the log of infinity, or what is the limit of log x as x goes to infinity? That's infinity. So altogether, this is infinity. So the area under that right half of the curve is infinity. So let's write that. What do you think will happen when we do the left half? So we'd say integral minus infinity to 0, 1 over absolute x plus 1 sine x dx. We know that x is negative here, so instead of absolute x, we can write negative x. We know that x is negative here, so we can write a negative 1 for the sine x. Is all the same math going to happen? Pretty much. But times the minus 1 there, so we're going to get negative infinity. So what we're getting is this area equals minus infinity. So overall, we just got this area is infinity, this area is minus infinity. So what's the overall area from negative infinity to infinity? It's really, really tempting to say that these cancel out and give you 0. And that would be true if we integrated from like negative 10 to 10, negative 100 to 100, negative 1,000 to 1,000. But for theoretical reasons, what we have to do is integrate one half, see if the answer exists, integrate the other half, see if the answer exists. But here, what we're getting, this infinite integral, this minus infinity counts as dne, and that infinite integral counts as dne. So overall, that limit does not, that integral does not have a single value we can say, so the integral diverges. Even though those things are perfectly symmetric, for reasons higher up in math, we have to say that that integral does not converge. So that's the interesting story with doubly infinite integration.